Experimenting further, he found that the same results were obtained using a bar magnet instead of the primary coil and ring apparatus. One of the most important conclusions from Faraday's experiments can be stated this way. As long as the magnetic field within the coil is changing, a current will be induced in that coil. This principle was used by French inventor Hippolyte Pixii in 1832 to develop the first electric generator. Although it was clear that induced current flowed in different directions, depending on whether a magnetic field was growing or collapsing, why it was doing this was a mystery. 2 years later, German physicist Heinrich Lenz provided the answer. He realized that the induced current generated its own magnetic field. But even more important, Lenz discovered that the induced magnetic field is always opposed to the change in the external magnetic field that caused it in the first place. As the south pole of the bar magnet approaches the coil, a south pole is induced at the near end of the coil. Opposing the forward motion of the bar magnet. The beauty of Lenz's discovery, now known as Lenz's law, is that we can identify both poles of the induced field. And we can use the left-hand rule for coils to determine the direction of the induced current. Remember that the thumb points toward the North Pole and the fingers curl in the direction of current flow. Once the bar magnet stops moving, the field is no longer changing, so there will be no induced current, and therefore no magnetic field. In other words, everything in the coil stops. Now, suppose we begin moving the bar magnet away. Once again, current flows, and a magnetic field is induced which opposes the movement, this time by establishing a north pole at the near end of the coil. The left-hand rule for coils shows that the current flows in the other direction.